Hello everyone, my name is Adrian Fernandez from Texas Instruments, and today I'm going to show you how to use the CC110L SubGHz RF booster pack. So this booster pack features a TI CC110L SubGHz RF transceiver. So we worked with a partner called Energia, and what they do is they take TI transceivers and they encapsulate them into these FCC certified modules. So it makes it really easy for customers to incorporate these components into their system solutions without having to worry about FCC certification, since Energia has already taken care of that at the modular level. And these modules communicate to a microcontroller over SPI. So that means this is strictly a transceiver, and you need a microcontroller device to host the protocol as well as the application layer. So in this particular example, I'm going to be using the MSP430 F5529 LaunchPad. However, this example or demo will work just the same on a TVC ARM Cortex M4F LaunchPad, as well as the original MSP430 G2 LaunchPad. So that's what's so great about these booster packs and the software abstraction that Energia provides, is that we can more or less have source code compatibility across multiple platforms. So I'm just going to plug these two things together, and I'm going to create my wireless sensor network here. So there you go. So now I've got my complete system. I've got my RF transceiver interfacing with my underlying microcontroller target device. So this is going to serve as a wireless monitoring system. So this is going to be communicating to another LaunchPad using this wireless module. And we're going to basically monitor an accelerometer. So when the accelerometer is shaken, an LED on this LaunchPad will turn on. And that all is going to happen wirelessly thanks to the SubGHz RF booster packs. So this booster pack actually comes with two of them. So when you order it, it's just $19.99. You get two RF booster packs. So out of the box, you can immediately start communicating bidirectionally and create a point-to-point wireless network. So this is going to be listening to our accelerometer. I'm going to plug this educational booster pack, which features a 3-axis accelerometer right there, and it's an analog accelerometer. So it's going to output 3 analog values through 3 analog channels, one for each of the accelerometer axes. So I'm just going to plug that onto my other 5529 LaunchPad. There you go. So now my MSP430 device is able to read accelerometer data. Next, I'm going to plug in the CC110L SubGHz RF booster pack on top. So now this system solution is getting a little bit more complex. We've got the accelerometer sensors. We also have now the SubGHz RF transceiver talking to the microcontroller device underneath. Just like that. So we got kind of a LaunchPad booster pack sandwich, if you will. So this is going to be the accelerometer side. This is going to be our sort of access point, or our hub, that will be basically monitoring our accelerometer. So that's it on a hardware standpoint. We are going to use a tool called Energia to program our LaunchPads, both sides of the system. So you can find more information on Energia here on this website, energia.nu. But more or less, it's a community-driven, community-developed, open-source software development environment. And in the latest version of Energia, I'm using version 11. It comes preloaded with some example projects for this particular booster pack. So we can actually see there's 2 flavors. There's an ETSI version and an FCC version. Since I'm in the US, I'm going to go ahead and use the FCC flavor. And the particular example that I will use is called wireless test. So I'm going to go ahead and click on that. So that'll open up a new window that has a wireless test example. And what this example does is it showcases that bidirectional communication. It shows how to transmit data as well as receive data. So I'll quickly run through the code so you have an idea of what functions are available inside of this library. At the very top, you have your sort of comment block, just talking a little bit about the library itself and the example, a couple of helpful links here. But the first thing we do is we import a few libraries. We import our SPI library, since that's the interface we're using to talk to the wireless booster pack. Then we're going to go ahead and import the library for the booster pack itself. Then we're going to declare a few global variables. The first one is an array that we call transmit data, or TX data, and that will hold the packet that we are going to send wirelessly. We also have a receive data array, and this will receive any data that our LaunchPad or booster pack receives. Then we have two functions that are created here. Print transmit data, basically going to send diagnostic information every time we transmit data to the hyperterminal. We also have a print RX data, which will send diagnostic data to the hyperterminal every time we receive something new over the wireless interface. Then down to the main example, we have the setup portion of our code, and this runs once at reset. So the first thing we need to do is we initialize our radio using a function called radio.begin. Then we initialize our serial using a function called serial.begin, and this is going to initialize that backchannel UART, which enables communication between the LaunchPad and the PC. And that's more there just for, again, that diagnostic information that we might want to see during development. Then we also have a status LED that we are setting up. So we're going to make an LED, set it as an output, and we're going to initialize it as low. So this LED, the red LED, is going to turn on anytime we're receiving any information. So we get that visual feedback on the LED here every time we're receiving some data. Then we have the loop portion of our code. So this portion of the code will just loop over and over again. And the first thing that we do in this example is we transmit. So we're going to transmit that data inside of the TX data array. So as we remember earlier, that was the array that was initialized as a global variable up here. And it's basically pre-populated with some arbitrary values. So in this case, air, you can kind of see it here. That's what's being sent. So that's the first thing we do in loop. We radio.transmit. Then we use the print transmit data function to sort of send that diagnostic data over the serial. Then we actually make some modifications to that array, the transmit data array. So we're going to basically increment that first character in that array from 0 through 9, so that every transmission is a little bit different. It'll say 0 air, 1 air, 2 air, 3 air, and so on, until it gets to 9, then it loops back to 0 again. And then that way each transmission looks a little bit different. And that's it on the transmit side. So the main function that you really care about is radio.transmit. On the receive side of the code, we have another function called radio.receiverOn. So that's a function that basically just turns on the receiver, checks to see if there's any new data available, and if so, stores it into the array called RX data. So this is the function that we could use to potentially check to see if our accelerometer has sent any new information. And that's it. So this particular example, we potentially could just load it straight up into our LaunchPads, same exact code on both ends, and they'll basically just start communicating bidirectionally back and forth to each other, sending that arbitrary value back and forth. And we're going to be able to see both the transmit and the receive data on our hyperterminal just to verify that everything is working properly. So that's something that you guys can go ahead and do on your own. However, we're going to actually use this code example as a starting point for our own particular application. Minimize this window here. So again, since we want to go ahead and monitor this accelerometer, let's program this side of the system first. So I'm just going to plug it in over USB here. There you go. So this is plugged in. You can see I've got power now. I've got my power LEDs turning on. I'm going to modify this example, and since we don't need to receive anything on this side of the system, I'm just going to comment out this side of the code. I'm just going to comment all of this out. There you go. So now all I have is the transmit side of the code. So I'm just cutting it in half basically and just keeping the transmit portion of the code. But this particular example transmits every loop. However, I only want to transmit when the accelerometer senses that it's been shaken. So I'm going to go ahead and insert some math and some logic here. And we'll walk through it one at a time. Alright, so I'm just going to paste a few lines of code that I've written earlier, and we're going to use a function called analog read. So that's a function that Energia provides to read out the current voltage value that's available at a pin. So the only parameter you need to pass in is the analog channel you want to read. In the case of this particular booster pack, the X, Y, and Z axis of the accelerometer are tied to A0, A1, and A2 of my 5529 LaunchPad. So I'm going to read the X-axis, the Y-axis, and the Z-axis, and store them into these three variables. I'm also performing some math, so I'm going to scale it down by 10. I'm going to divide them by 10, and that way the numbers aren't so big. Sure, I lose some resolution, but I think for the purposes of our particular application, it's okay. And I'm dividing it by 10 so that when we do some further math to it, we don't overflow the variable. So I'm just going to divide it by 10 first. Then I'm going to translate the values down by 205. So this way it's a little bit more centered, and this makes me allows me to do math on it a little bit more easily. And that's it. So that saves my X, Y, and Z values coming out of my accelerometer. Most of the work was done by the analog read function that Energia provides. So now that we have the values of each of our analog accelerometer channels, we want to go ahead and perform a sort of resultant vector algorithm to it. We want to figure out what the total amount of force is being exerted to the LaunchPad. And we can do that using the x squared plus y squared plus z squared algorithm and getting the square root of that. So that's, I think, what's popularly known as the distance formula. So this allows me to find what the resultant force is of my LaunchPad. Then I'm going to go ahead and normalize it to 100 using this value here. So I'm going to multiply by 100, then divide it by 82. So this will basically normalize it to 100 so that when my LaunchPad is perfectly still, the total amount of force is just 1g. So the only force available is gravity. So 1g is going to be about 100, thanks to the little math that I'm doing here. 1.3 Gs will appear as 130, 1.5 Gs will appear as 150, 1.1 Gs will appear as 110. So it's normalized at 100 here. So now that we know that, I'm going to go ahead and use an if statement. And I'm just going to paste that in here. There we go. So if the result is greater than 1.35 Gs, then I know that my accelerometer is probably being shaken. And at that point, I'm going to change the values of tx data, which is the array that was previously defined, and I'm going to replace the values with the word alarm. So now, instead of sending that arbitrary 0 error, 1 error, 2 error value, I'm just going to send the word alarm inside of my packet. Then I'm going to use the same radio.transmit function to send that out wirelessly. Then I'm going to print that data out to the serial monitor for debug purposes. If the result is less than or equal to 135, meaning that the accelerometer probably isn't being shaken, then I just basically blank out that transmit data value, and then that way nothing is being sent. It's basically a blank packet. And that's it. Then I can actually get rid of the rest of the code, so we don't need any of this anymore, which was originally part of our original code example. So this here is basically the transmit side, or the accelerometer side of our system. So I'm just going to go ahead and hit this button here to program it to our LaunchPad. There we go. So Energia should compile the code that we just written, and it will then upload it to our LaunchPad device. Just let it finish there. You can see it's racing, programming in this little console. There we go, it's done. So now that it's been programmed, we can actually test this out a little bit. So I can go ahead and hit the serial monitor button that's inside of Energia. Whoops. I need to make sure I select the right serial COM port 70 in my case. And now when I shake the LaunchPad, you can see that my alarm function is, or my alarm array is popping up here, only when I shake it. So that's great. So we can see that we're actually sending quite a lot of it because I'm shaking it pretty hard. So my resultant vector is jumping all over the place. But it's okay. We can take account of this in the receiving side of the system. So there you go. And you can see there's a few other characters here, and that's more or less the preamble and the end bits of my transmission. But really, all I'm going to pay attention to is the first 6 characters of the array, and that's what I'm gonna look out for on the receive side. So there you have it. You can see it's working every time I shake it. I'm getting new data in my serial monitor here, and you can see my vertical scroller gets smaller as I get more and more data as I shake it more and more. So there you go. So the the transmit side is working just fine. So I'm just going to go ahead and unplug it now from my computer. So the code is stored in Flash, so we're in good shape there. Now we're going to program the receive side, which is this guy. This guy is going to be basically listening for this alarm function or this alarm array that we just sent out on the transmit side. So take this guy, plug it into our LaunchPad, to our computer. There you go, plugged in. We've got our power LED on. Close the serial monitor. And now I'm going to go ahead and comment out the transmit code that we just wrote. We don't need that anymore. However, I would like to uncomment the receive code that I commented out previously. Oops. Let's see here. So I'm just going to get rid of all of these comments here to open up the code. There you go. So this is the receive side of the code example. So again, we just cut it in half. Now we're looking at the other half of the code, which is the receive side. And here we have some logic. So if receiver on, if there is data to be received, we can go ahead and perform some logic. We're going to go ahead and put in an if statement because the radio is putting in any received data into this RX data array. So I'm just going to perform an if statement to it, and I'm just going to copy and paste that because I wrote it earlier. There you go. And we're basically just going to compare each element of the array. So if RX data 0 is equal to A, RX data 1 is equal to L, RX data 2 is equal to A, R, M, exclamation point, then we know that alarm was sent by the accelerometer. If so, we're going to turn the green LED on. We're going to wait for 1.5 seconds or 1500 milliseconds, then we're going to turn that green LED off. So basically this green LED should only turn on when the alarm array is received. And that's it. And that should really just do it, I think. So we're going to go ahead and program the LaunchPad with this receive code. So we're going to hit that button here to compile and download it. There we go, compiling. There we go. It's now trying to upload it into the LaunchPad device. And done. Great. So now this guy is ready to go. It's just waiting for the appropriate packets to come in. And you can see that by default, my green LED is off. Okay. And since this guy already has code loaded into it, I'm just going to go ahead and plug it in over USB to give it power. And then immediately I should start monitoring that accelerometer and sending out that alarm whenever the threshold is exceeded. So I'm just going to plug it in here to my other USB cable. There we go. And try to get both of them in a frame here. So as you can see, as I'm not shaking my my LaunchPad here, so it shouldn't be sending any information or sending any data. There you go. So once I shake it, hopefully the green LED on this guy should turn on. So here we go. Not working. Well, maybe I have to hit reset. Reset both of them. Oh, there we go. I just had to hit reset. So I reset both of them. So now they should both be executing the code they were programmed and loaded into. So I'll give this guy a shake, and there you go. The green LED turns on. Give it a shake again. Perfect. So what's basically happening is the green LED on this board only turns on when it receives the alarm array that was being sent wirelessly by this guy. So let's do it again. There you go. So it works pretty well. So what's great about this is that this is just a really simple application. I just showed you how to build something from the ground up in just a couple of minutes, not too bad. But what's an accelerometer in this case could very well be the joystick. It could be the temperature sensor or the light sensor that's also on this booster pack. It could be a humidity or temperature sensor, whatever it is you have. So you can basically wirelessly monitor various types of sensors and send it to another wireless device. So it's just a really good way of providing a proof of concept or rapidly prototyping a wireless solution. So you can see it works pretty well. And then obviously we can change that threshold to whatever value so that it's more sensitive or less sensitive depending on your use case. But lots of applications could be enabled by this particular technology. But hopefully this shows you just how quickly you can prototype with LaunchPads and booster packs and the Energia tool. So you can find more information on this ecosystem at ti.com/launchpad. And you can find more information on the software tool at energia.nu. So again, the part numbers we're using here is 430 Boost-CC110L. Comes with 2 RF booster packs for $19.99. We're using the educational booster pack Mark II from Circuit Co., which features the accelerometer. And we're using 2 MSP430F 5529 launch pads. However, again, this exact same application, exact same code, will work on a Tiva C LaunchPad as well as the MSP430 G2553 LaunchPad. And that's it. Thanks for watching. Hopefully you guys learned something. Thank you.